Yes, good evening students. In the last class we discussed about some questions regarding the states of matter, continuation of those questions, right? Now regarding continuation of those questions, what we discuss? Come to the class immediately. Please come to the class immediately, Nana. In the last session, we completed some questions on states of matter, continuation of those questions. See the next one. Derive ideal gas equation. See, Nana. So what is ideal gas equation? PV is equal to nRT. This ideal gas equation is also called what? Is also called equation of state. What I am said, also called what, Nana? Equation of state. So how you derive this equation of the state? According to your very well known Boyle's law, volume of the gas inversely proportional to what? Pressure of the gas at constant temperature. That is according to Boyle's law, right, students? And come to the Charles law. So the volume of the gas proportional to the temperature on the Kelvin scale. So this is according to Charles law. And according to Avogadro's law, the volume of the gas proportional to number of moles of the gas. This is according to what? Avogadro's law. Now, by combination of all these laws, on the left hand side, volume of the gas, volume of the gas, volume of the gas is available. Yes or no, students? Repeat once again, Nana. According to Boyle's law, so the volume of the gas directly proportional to 1 by P. According to Charles law, the volume of the gas proportional to what? Temperature. According to Avogadro's law, the volume of the gas proportional to what? So the volume of the gas proportional to, so number of moles of gas. That is according to Avogadro's law. By combination of all these laws, so what you got? By combination of all these laws you got, so the volume of the gas proportional to 1 by P into temperature into number of moles. To remove the proportionality, you make a constant. That means what you write? Proportional to T into N by P. Now to remove the proportionality, what you write? So volume of the gas is equal to K into Tn by P. Here K means what? K is proportionality constant. The K is replaced by the R value. What is R value, Nana? Universal gas constant value. Tell me what I am saying. What is the R value? Universal gas constant value. Okay, Nana, listen. Yes. Now basing on that, so now what you write? Now you write like this. So V is equal to R into T into N by P. That is equal, PV is equal to nRT. So this is the ideal gas equation. For 1 mole of gas is taken, tell me what I am saying, students. For 1 mole of gas is taken, what you write? PV is equal to RT, you write. That is, for 1 mole of the gas is taken. Is the simple explanation of the what? Simple explanation of derivation of what? Ideal gas equation. I add one more 2 marks question here. Define ideal gas and define real gas. So one small difference there is there between the ideal gas and real gas. Now see, in ideal gas, in between the gas molecules, what I have said, in between the gas molecules, the force of attractions, the forces of what? The forces of attractions and forces of repulsions are absent. What I am saying, forces of the attractions and forces of repulsions are absent. If the force of attractions, forces of repulsions are absent, they are called what? Ideal gas. Come to the real gas. So in the real gas, what are there? In the real gas, in between the gas molecules, tell me what I am saying, students? In between the gas molecules, either force of attractions, what I am saying, either force of attractions or force of the repulsions are present. What I am saying, either force of attractions or force of repulsions are present. That is the meaning of what? That is the meaning of the real gas. This is one of the important 2 marks question. Understood what I am saying? Repeat once again. So Charles law is very easy, JN. What is Charles law, JN? Volume of the gas directly proportional to temperature on the Kelvin scale at constant pressure. That is called the Charles law. Easy, Nana? No confusion of the Charles law, right, JN? Understood, Nana? Yes. So what is the ideal gas and what is real gas? In between the gas molecules, force of attraction, force of repulsion are absent. That is called ideal gas. Come to the real gas. In the real gas, in between the gas molecules, either the force of attractions, either the force of repulsions are present. That's the important 2 marks question may be given. Yes. Now see the next one. Explain the physical significance of the van der Waals parameters. First of all, what is the van der Waals equation? Simple equation. T plus an square by v square into v minus nb is equal to nRT. That is the simple equation. Understood? T plus an square by v square into v minus nb is equal to nRT. For 1 mole of the gas is taken. Number of moles of gas is what? For 1 mole of the gas is taken, what you write? You write as P plus A by V square into V minus B is equal to RT. This is for 1 mole of the gas. Now we discuss about the physical significance of the van der Waals parameters. First we discuss about the A significance. Actually, so in the van der Waals equation, A explains what? A explains the intermolecular attractive forces. A explains the intermolecular force of attractions. A explains intermolecular force of attractions between the gas molecules. Understood, Nana? That means the gas with more A value, the gas is ready to liquefy. The gas is what? Ready to liquefy. Which gas is ready to liquefy? The gas with more A value, the gas is ready to liquefy. Why the gas with more A value is ready to liquefy? Because in that gas the force of attractions are more. What I am saying, Nana? In that gas the force of attractions are more. In that gas the force of attractions are more. The gas is ready to be liquefied. Understood what I am saying, brother? Yes. What is the significance of A? Repeat once again, Nana. A explains what? The intermolecular force of attractions between the gas molecules. The gas with more A value, those gas molecules are easy to be liquefied. And compared to the significance of what? Significance of the B. Now see, B explains what? The B explains the size of the gas molecules. B explains the size of gas molecules. How the B explains the size of the gas molecule? That means the gas molecule with the more atomicity, the size is more. For example, you take the methane gas, atomicity is 5. Okay, in the ozone gas, atomicity is 3. Understood? In the helium gas, atomicity is 1. That means which is the big size? Methane gas big size than ozone. Ozone is big size than helium, like that. That means the B explains what? Size of the gas molecules. Tell me what I am saying, Nana? B explains size of the gas molecule. See, as size of the gas molecule is more, what I am saying, Nana? As size of the gas molecules are larger, as size of the gas molecules are larger, so those gases are difficult to liquefy. What I am saying? Those gases are difficult. Those gases are difficult to liquefy. Understood? What am I saying? Why those gases are difficult to liquefy? Because it is difficult to compress the gases. The size is small, easy to the miscibility of the gases. If the size of the gases are more, it is difficult to liquefy the gases. That is the meaning of the B. Sometimes in the examination paper may be given units of the A, units of the B. Now go to the units of the A. That is also important. It is not there, but is given as the IPE question. Units of the A and units of the B. Regarding units of the A and B, what you write? P is equal AN square by V square. Now A is equal, pressure means what? Atmosphere. V square means what? Volume square per mole inverse square. Units of the A. Come to units of the B. V is equal to NB. NB means what? Liter per mole. What you write, Nana? Liter per mole. So this is the units of the A and B. What I am saying, brothers? Units of what? A and B. Simple logic, no confusion. Understood, Narendra? Narendra, Jain, Saranandam. Narendra. You are Narendra. Okay. Right. So this is over. And see the next question. So that is completed. So, and go to the next question. So the questions are not there. And see the now very short answers now. So now discuss about very short answers. Explain the significance of the pattern parameter is completed. Here the questions are not there, but I am explaining the questions. See the next question. What is vapor pressure of liquid? How the vapor pressure of liquid related to the boiling point? See, continuation of the question. Next question. What is vapor pressure of liquid? So those questions are not typing. Don't worry, I am writing the question because writing a question is very easy now. Yes, Nana. Naresh, I don't know actually how many items are there. Okay, Nana, I don't know that. So what is vapor pressure of liquid? How the vapor pressure of liquid? How vapor pressure of Narendra? I don't know how many items there for JEE Mains in 2022 because of the COVID situation. Okay, I don't know, Nana. What is vapor pressure of the liquid? What are the vapor pressure of the liquid? How the vapor pressure of the liquid related to the boiling point? Related to what? Boiling point of the liquid. Simple explanation. Right, Nana? Right. Now see that. Simple. First of all, how you define the vapor pressure of the liquid? Simple logic. So, the vapor pressure of the liquid is defined as the vapor pressure of the liquid defined as the pressure exerted by. Tell me what I am saying. The pressure exerted by the vapor molecules. The pressure exerted by the vapor molecules are in equilibrium. What I am saying, Nana? Are in equilibrium with the surface of the liquid. Are in equilibrium with what, Nana? Surface of the liquid. That is the meaning of the vapor pressure. Repeat the statement once again, Nana. Yes, Nana. Okay. So how you define it once again? So vapor pressure of the liquid is defined as, Nana, the pressure exerted by the vapor molecules. The pressure exerted by the vapor molecules are in equilibrium with the surface of the liquid. Understood? That is the meaning of vapor pressure. How this vapor of the liquid is related to the boiling point? Simple explanation. Generally, so first to define what is the meaning of the boiling point. Simple statement, Nana. See, the boiling point is defined as, so what is the simple statement? So the boiling point is defined as the temperature, tell me what I am saying, the temperature at which the vapor pressure of the liquid, what I am saying, the temperature at which vapor pressure of the liquid equal to the outside, what I am saying, equal to the outside atmospheric pressure. Equal to what, Nana? Outside atmospheric pressure of pressure. That is the meaning of the boiling point. Repeat the statement once again, Nana. So what is the statement I said? Boiling point means what? The temperature at which the vapor pressure of the liquid equal to the outside atmospheric pressure. Tell me what I am saying. The temperature at which vapor pressure of the liquid equal to the outside atmospheric pressure. That is the meaning of what? That is the meaning of boiling point. Yes. Now see, generally, so here vapor pressure of the liquid is more, the boiling point of liquid is less. What I am saying? So the boiling point of liquid is what? Less. That means what? So the liquids with a low boiling point, they are ready to be vaporized. What I am saying, Nana? The liquids with low boiling point are ready to be vaporized. For example, say, what I am saying, the boiling point of the ether is what? 35 degrees. Understood, Nana? The boiling point of the water liquid, the boiling point of water liquid is 100 degrees. Now, basing on the boiling point of the ether 35, basing on the boiling point of water 100, so which liquid can show more vapor pressure? The liquid with boiling point of the ether 35 can show what? More vapor pressure. The boiling point of water is 100 degrees, it can show what? Less vapor pressure. Why? Because of the here, in the water, intermolecular forces are stronger. What I am saying? Intermolecular forces are stronger in the water. So in the ether, the intermolecular forces are weaker. That is the simple logic. That means the boiling point of liquid depends on what? molecular forces. What I am saying depends on intermolecular forces. You can write the concept like this because the 4 marks question, brother. And you write the last point regarding that. You write like this also. On x-axis, temperature over liquid increases. Temperature over liquid increases. On the y-axis, so we write vapor pressure of the liquid. What you write now? Vapor pressure of the liquid. Now, as temperature over the liquid increases, vapor pressure of the liquid increases exponentially. Increases what, brother? Increases exponentially. One of the beautiful, nice statement. Repeat the point once again. Over the liquid, as temperature increases, the vapor pressure of the liquid increases what? Exponentially increases. One of the beautiful, nice statement. Right, Nana? So you can write like this. You got full marks. Right, brother? Yes. And see the next question. So successfully the 4 marks questions in the state summit is over. And go to the very short answers. You go to what, brother? Very short. Now regarding very short, so here I have no questions for typing. I am writing the question, don't worry, Nana. So see that. What are isotopes? See the first question. So what is the meaning of the isotopes? Isotopes means what? So the pressure of the given gas inversely proportional to the volume of the gas at constant temperature. At what, Nana? At constant temperature. That is called what? Isotope. Repeat once again. The pressure of the gas inversely proportional to the volume of the gas. Okay, at constant temperature, that is called what? Isotope. This is one of the best example of the statement of what, Nana? Boyle's law statement. See, what is the statement of Boyle's law, brother? The volume of the gas inversely proportional to the pressure of the gas. That means, for example, say, on the x-axis, so the volume of the gas increases. On the y-axis, the pressure of the gas increases. As volume of the gas increases, pressure of the gas decreases exponentially. Decreases what, Nana? Exponentially. That is the meaning of isotope. And second question, Nana. Second question. See the second question. What are STP conditions? Simple logic. What are STP conditions? What is STP? Standard temperature pressure. So 0 degrees Celsius or 273 kelvins. The temperature taken as the standard temperature, and pressure taken as what? 1 atmosphere, that is equal to 760 mm of mercury. That is, pressure is taken as the standard temperature and pressure. That is called STP conditions. Come to the third question. What is gram molar volume? Now see. So third question, Anna. What is gram molar volume? Simple statement. So gram molar volume means the volume occupied by the 1 mole of the gas is called gram molar volume. Repeat once again. The volume occupied by the 1 mole of the gas, is called gram molar volume. That gram molar volume is equal to 22.4 decimeter cube, or the same thing you write 22.4 liters. That is the gram molar volume, because 1 decimeter cube is equal to what? 1 liter. Right. Next one. Why the gas constant is called universal gas constant? See the fourth question. So what, Narendra, you doubt? Isobars. Isobars means what? The pressure is constant. Volume of the gas directly proportional to. Chakali, your name that one? Isobars. Okay. Your name is Narendra. Okay. So isobars means what, brother? At constant pressure, volume of the gas directly proportional to temperature. What I am saying? At constant pressure, the volume of the gas directly proportional to temperature. That is called isobar. Right? And come to the fourth one. Why the gas constant is called universal gas constant? Understood? Yes. Simply said, because the gas constant is derived from what? Gas constant derived from all the gas laws. Gas constant derived from the all gas laws. All gas laws means what? From Charles' law, Boyle's law, Avogadro's law. That's why that gas constant is called universal gas constant. Repeat the statement once again. So what is gas constant? Universal gas constant means the gas constant derived from the all the gas laws. Derived from the what? All the gas laws, that is called what? Universal gas constant. And see next one. Which of the following are diffusing faster among N2, O2, methane and why? See the example of N2 gas. Its molecular weight is 28 grams per mole, and O2 gas. Its molecular weight is 32 grams per mole. For methane gas, its molecular weight is 16 grams per mole. So out of these given gases, which gas diffusion is faster? The gas with what? Less molar mass of 16 diffusion is faster, because rate of diffusion of the gas is inversely proportional to square root of the molecular weight of the gas. Repeat once again. Rate of diffusion of gas inversely proportional to square root of what? Molecular weight of the gas. Simple logic, no confusion. And see the next question. How many times methane diffusion faster than sulfur dioxide? How many times methane is diffusion faster? See, rate of diffusion of the methane by rate of diffusion of what? SO2. So inversely proportional to what? Square root of molecular weight of the SO2 by molecular weight of the methane. So from that, so molecular weight of SO2 is what? 64. Methane is what? 16. And what you get? 4 by 1, that is equal to 2 by 1. That means rate of diffusion of the methane 2 times faster. Tell me. So 2 times faster than rate of diffusion of what? SO2 gas. Simple question. And see next question. So what give the relation between partial pressure of the gas and its mole fraction? Asking about relation between partial pressure of the gas and mole fraction. Simple relation is there. So it's a 2 marks question. Just you write like that. So partial pressure of the gas is equal to mole fraction of that component into total pressure of the gas. Into what? Total pressure of the gas. Understood what I am saying? Partial pressure of the gas is equal mole fraction of the gas into total pressure of the gas. Just to write like that. And how you define that? Because it's a 2 marks question, that is enough. How you define the partial pressure of the gas, Nana? The pressure exerted by the gas molecule. What I am saying? See, partial pressure of gas means what? The pressure exerted, EXERT, the pressure exerted by the gas molecules among the non-reacting gases. Among the what? Among the non-reacting gases. Among the non-reacting gases. That is the meaning of what? Partial pressure of the gas. Repeat the statement once again. The pressure exerted by the gas molecules among the non-reacting gases at given temperature. That is the what? That is the partial pressure of the gas. Understood? And see the next one. What is aqueous tension? Simple question. See, what is aqueous tension? Simple explanation, no confusion. See, aqueous tension means the pressure exerted by, what I am saying, the pressure exerted by the water vapor, the pressure exerted by the water vapor along with the collection of the dry gas. Along with what, Nana? Collection of pressure of dry gas. Collection of what I am saying? Collection of the pressure of the dry gas. Simple statement, no confusion of the statement. Repeat once again. What is aqueous tension? Aqueous tension means the pressure exerted by the water vapor along with what? Collection of the pressure of the dry gas over water surface. Over what? Over water surface. That is the meaning of what? Aqueous tension. Right? Understood what I am saying? And see the next question. It is very easy. So what is Boltzmann's constant and give its value? So next question is what? Boltzmann's constant. Now regarding that Boltzmann's constant. See what is the Boltzmann's constant? The Boltzmann's constant is nothing but K value. That means Boltzmann's constant K is equal universal gas constant by Avogadro number. So what is universal gas constant? 8.314 joules by Avogadro number. 6 into 10 power 23. Unsimplified you get 1.33 into 10 power minus 23. What you get? 1.33 10 minus 23 joule per molecule. What I am said? Joule per molecule. Simple logic, no confusion. That is called what? Boltzmann's constant. And next question is a very 2 marks question. It's very easy, brother. Not difficult. 2 marks questions. See, what is next one? What is RMS velocity? Simple statement. How we write RMS velocity? Root mean square velocity of the gas molecules which are moves in all directions. Repeat once again. So what is RMS velocity? RMS velocity means root mean square velocity of the gas molecules which are moves in all directions. Which are moves in what directions? All directions. Therefore, RMS velocity of the gas equal what you write? N1C1 square plus N2C2 square plus N3C3 square by N1C1 plus N2C2 plus N3C3 go on like that because of the root mean square velocity. Also write the same formula. RMS velocity equal root over 3RT by M. One more shortcut formula is there for RMS velocity. Easy explanation, no confusion of the explanation. Right, Nana? And see next one. What is compressibility factor? Next question is what, Nana? So what is compressibility? What is compressibility factor? Actually, the compressibility factor, the symbol taken as what? The symbol taken as the Z. Actually, so the Z explains what? The Z explains the deviation of what? The Z explains deviation of the real gas behavior. Deviation of the real gas behavior. Real gas behavior from the ideal gas nature. From the what nature? From ideal gas nature. That is the meaning of the compressibility factor. Repeat the statement once again. Nana. So Z explains what? Deviation of the real gas behavior from the ideal gas nature. Therefore, Z is equal to what you write. So molar volume of the real gas. Tell me. Molar volume of real gas by molar volume of what? Molar volume of the ideal gas. Right, Nana? Right. This is the formula of the Z. Simple explanation. Repeat the explanation once again. So what is compressibility factor Z? The compressibility factor Z explains what, Nana? Deviation of real gas behavior. Tell me. Deviation of what, Nana? So the deviation of the real gas behavior from the ideal gas nature. Z explains deviation of the real gas behavior from the ideal gas nature. Therefore, Z is equal molar volume of the real gas by molar volume of the ideal gas. And next one, see what is Boyle's temperature? Simple statement. How do you define the Boyle's temperature? Simple explanation. See, Boyle's temperature, the symbol taken as TB. So nothing but the temperature at which, simple statement, Nana, the temperature at which the real gas molecules behaves like what? The temperature at which the real gas molecules behaves like ideal gas molecules. Real gas molecules are behaves like what? Ideal gas nature. That is the meaning of Boyle's temperature. Therefore, Boyle's temperature PV is equal to A by RT. What is the formula, Nana? Boyle's temperature PV is equal to what you write? A by RT. What is A? Van der Waals constant. What is B? Van der Waals constant. Therefore, A comma B explains what? Van der Waals constants. Simple statement, brother. So, what is Boyle's temperature? The temperature at which what? The real gas molecules behaves like what? Ideal gas molecules. Understood? Yes. And see, why the pressure cooker is used for cooking of the food on the hills? Simple logic. Because on the hills, the outside atmospheric pressure, on the hills, the outside atmospheric pressure should be less than atmospheric pressure available on sea level. Should be less than what? Available on sea level. Therefore, because the atmospheric pressure on the hills is less than what? Atmospheric pressure available on the sea level. That's why the cooking of the food items requires more time. Cooking of food item requires what, Nana? More time, because the cooking of food item requires more time. Therefore, we can use the pressure cooker. Simple logic. And just to repeat once again. So on the hills, the outside atmospheric pressure is less. Okay, compared to what? The atmospheric pressure available at the sea level. Therefore, because outside pressure is less, so the boiling point of the temperature also less. That's why cooking of the food item requires the more time. Okay, that's why we can use the what? Pressure cooker. Next one. So what is the critical temperature? There are some question. So what is critical temperature? All the students is clear. See, what is the meaning of critical temperature? In the shortcut, you taken as what? TC. Now regarding critical temperature. So how you define the critical temperature? The temperature at which the temperature, simple statement, Nana. The temperature below it, the gas molecules, the temperature below it, the gas molecules are to be, the gas molecules are to be liquefied. The gas molecules are to be what, Nana? The temperature below it, the gas molecules are to be liquefied, and above it, the gas molecules are difficult to liquefy. Above it, the gas molecules are difficult to liquefy. Difficult to what, Nana? Difficult to the liquefy. It's the simple explanation, no confusion. Therefore, TC of the CO2 gas is what? The TC of the CO2 gas is 31 degrees Celsius. In terms of the kelvins, what you write? 304 kelvins you taken. What you write, Nana? So 304 kelvins is taken. Repeat the bit once again, Nana. The temperature below it, the gas molecules can be liquefied. Above it, the gas molecules are difficult to be liquefied. That is the meaning of critical temperature. Therefore, critical temperature CO2 gas is what? 31 degrees Celsius or 304 kelvins. Understood what I am saying? Yes, Nana. And see, what is surface tension? Simple statement, Nana. Now come to the concept of the surface tension. Actually, the surface tension of the liquid is defined as, how we define? So the force exerted by the liquid, the force exerted by the liquid, the force exerted by the liquid over on the length of given surface of liquid, length of given surface of the liquid, length of given surface of liquid. Therefore, surface tension is equal to force acting per unit length. Force acting per what, Nana? Unit length. Simply said that the force acting perpendicularly to the unit length of the given surface of liquid. Okay. The force acting perpendicular to the given length of the surface of the liquid, that is called surface tension. That is what you write. Newton per meter. Therefore, the units of what? The units of the surface tension is what? The units of surface tension is Newton per meter. Any doubt you having? Simple explanation, no confusion. Clear, Nana? So what are the units of surface tension? Newton per meter. Repeat once again, Nana. So how you define the surface tension? Simple statement. See, the surface tension is defined as the force. So what is your doubt, Nana? Telugu academic material. Yes, Nana. Telugu academic material is better for EAMCET. Yes, Nana. Sahib, that's better. That is called surface tension. And see next one. So what is the coefficient of viscosity? Give it units. Simple statement. So coefficient of viscosity, how you get, Nana? Force is equal to viscosity into dV by dx. Notice eta is called what? Eta is called what, Nana? So that is called coefficient of the viscosity. Coefficient of what is the viscosity? Now force means what? The force means, simply said that, into area of the given length. That is the simple logic. And refer this formula, Nana. I don't know. Refer the formula is there in the textbook. Okay, Nana? Refer that formula. Coefficient of the viscosity and its units. Yeah, correct, Nana? Yes, the quotient of viscosity force is equal to what you write, Nana? Eta into dV by dx.
Yes,
Okay. Okay, right. Now here force is what, Nana? Newtons. Quotient of viscosity. So velocity means what? Meters per second. And distance means what? Meters. And one more thing is there, I think so, into area of contact. Yes. Area of the contact. Area of contact is what, Nana? Meters square. Now it comes. Very good. So therefore eta is equal to what? Newton second meter power minus 2. Very good. That's exactly correct. Now here repeat once again. So force is equal. Eta means what? Eta means quotient of the viscosity. So this is the what? This is called velocity gradient. dV by dx is called what? No, velocity gradient. And A means area of the liquid contact. Area of what? Liquid contact. Now force means newtons. Velocity means meters per second. Dx means change in the volume of the length of the liquid. And area means meters square. And cancel you get Newton second meter power minus 2. What you get, Nana? Newton second meter power minus 2. That is the quotient of what? Quotient of the viscosity. And you are very well known. What is Newton? Newton means what? 10 power 5 dynes. Okay. Second has to write second. So this is 10 power minus 4 centimeter square. That is equal to what you write? 10 dynes second. 10 dynes second centimeter power minus 2. Therefore, 1 Newton second meter power minus 2 is equal 10 dyne second centimeter power minus 2. Now here, simply said that, therefore, dyne second centimeter power minus 2 is equal to what you write? 0.1 Newton second meter power minus 2. Now here, this is very important. Actually, the quotient of viscosity is measured in terms of the foci. In terms of what, Nana? Foci. Therefore, 1 foci equal how much? 1 foci equal 0.1 Newton second meter power minus 2. Tell me once again what I have said, Nana. 1 foci is equal to 0.1 Newton second meter power minus 2. That is 1 foci value. Units of quotient of viscosity measured in foci. So therefore 1 foci equal to what? 0.1 Newton second meter power minus 2. And see next one. Kinetic energy of the 5 moles of nitrogen at 27 degrees Celsius. Simple logical question. So kinetic energy of what? Kinetic energy of the nitrogen gas for 5 moles. So therefore kinetic energy of nitrogen gas 5 moles equal what you write? 3 by 2 nRT. That is equal what you write? 3 by 2. Number of moles means what? 5 moles. And R value in terms of the calories. 2 calories and temperature is 300 calories. 2 is cancelled. That becomes what? 4,500 calories. That 4,500 calories is equal to 4.5 kilocalories. This is the kinetic energy of what? Kinetic energy of the N2 gas in kilocalories. Repeat once again, Nana. What is the formula for kinetic energy of the N2 gas? 3 by 2 nRT. N means 5 moles of gas is taken. R value in calories to temperature is 300 kelvins. You get 4.5 kilocalories. That is the kinetic energy of what? N2 gas. And state Boyle's law and mathematical expression. That is very easy. Pressure of the gas inversely proportional to volume of the gas. That is called Boyle's law. What is the mathematical relationship? PV is equal to constant K. Next one. What is isopores? This one is what, Nana? What are isopores? Isopore means what, Nana? Volume is constant. That means pressure of the given gas directly proportional to temperature of the gas at constant volume. At what I am saying? At constant volume. That is the meaning of what? Isopore. Pore means what? The volume is constant. Repeat the statement once again, Nana. The pressure of the gas is directly proportional to temperature of the gas at constant volume. Now based on that, so the pressure of the gas is equal to K into temperature of the gas. So from that, what you get? P1 by P2 is equal to T1 by T2. What you write, Nana? P1 by P2 is equal to T1 by T2 at constant volume. And see next one. Define RMS speed of the N2 gas at 27 degrees. So what is the formula for RMS velocity? See, RMS velocity of N2 gas. Simple logical. RMS velocity of N2 gas formula is what? Root over 3RT by M. Root over 3RT by M means what you write, Nana? 1.58 into 10 power 4 centimeters per second root over T by M. What is the formula you write? So RMS velocity of input gas equal root over 3R T by M. That equal 1.58 into 10 power 4 centimeters per second into root over T by M. From that what you write? 1.58 into 10 power 4 centimeters per second. Temperature means what is the temperature is given? 27. That means what? 300 kelvins. And molecular weight is what given? 28 grams. Now once simplified, you get the answer. Now what you get now? 1.58 into 10 power 4. Root 3 means what? 1.72. Root 100 means 28 by root 28. So root 28 means how you write now? So root 7 into 2 is 7. Okay. So you write as so 6 6 are 24. Yes or no? Just you write like this. Root 28 means you write as so 16 2s are 32. Okay. 7 4s are 28. Yes, 7 4s. That means what you write here? 2 root 7 you write. You write as 2 root 7 unsimplified. You get the answer in centimeters per second. Simple logical question. Simple logical question. There are no confusion. Repeat the question once again. So RMS velocity formula is 1.58 10 power 4 centimeters per second. Temperature in what? Temperature in the Kelvin scale is 300 kelvins and molecular weight is 28 and substitute the values you get the answer. So this is your questions and see the next question. What is the effect of temperature on surface tension viscosity? Give reasons to that. Yes, simple logical question. Actually, so as temperature increases, what happens as temperature increases, surface tension of the liquid decreases. Why as temperature increases, surface tension of the liquid decreases? Due to decrease in what? Due to decrease in intermolecular forces of attractions. What I have said? You decrease in what, Nana? Intermolecular forces of attractions. Repeat once again, Nana. As temperature of the liquid increases, surface tension of liquid decreases due to decrease in intermolecular force of attractions. Same like that, as temperature increases, viscosity of the liquid, quotient of the viscosity of liquid also decreases. Because viscosity means what? The resistance of liquid to flow. Okay, that means what? So liquid viscosity is more difficult to flow on the surface. Viscous liquid is less easy to flow on the surface. That's why as temperature increases, again intermolecular force of attractions are decreases. Because of decrease of this intermolecular force of attractions, quotient of viscosity also decreases. Nana, easy logic, Nana. Understood what I am saying, Nana? Because what is viscosity? The resistance of the liquid to flow over the surface. That means the liquid has a more viscosity, difficult to show the movement on the surface. The liquid have the less viscosity, easy to flow on the surface. As temperature of liquid increases, intermolecular forces in the liquid decreases. By that viscosity also decreases. Simple logic, no confusion. And see the next question, Anna. So, ratio of the kinetic energy of 3 grams of H2 gas and 4 grams of the O2 gas at given temperature. Ratio of the kinetic energies. Now see that? Ratio of what? Kinetic energy. Now see that? Kinetic energy of what? H2 gas by kinetic energy of what? Kinetic energy of the O2 gas. So what is the formula for kinetic energy? 3 by 2 nRT by what you write? 3 by 2 nRT. R is cancelled. 3 by 2 cancel. 3 grams means what you write, Nana? 1.5 moles. Temperature given how much? At given temperature. Temperature T is there. Again here how many grams given? 4 grams. 4 grams means what? 4 by 30. Where the pushes are there? 4 by 32 into temperature. Now it's cancelled. Exactly 8 times cut off. And you get what, Nana? 9 by 1. This is what? 9:1. Simple logical question. Understood what I am saying? So this is your complete state sum matter topic. What topic? State sum matter topic. And go to the stoichiometry. One of the excellent topic. Here also you get what? So very short as well as short answers. In stoichiometry part, you got very short as well as the short answers. And see the first today class we discuss about very short answers. Now, discuss about very short answers to the today class. Okay. And that is over there. This is the first one is over. Day before it is completed, Nana. And see how many number of moles of glucose present in 540 grams of the glucose. How many moles of glucose? See the first question. See the first question. How many moles of glucose? How many moles of the glucose present in 540 grams of the glucose? How many moles of glucose present in 540 grams of glucose? What is the formula for number of moles of the glucose? Number of moles of the glucose given weight is what? 540 grams. By what is the molecular weight of the glucose? 180 grams. Grams cancel, 0 cancel. Exactly, you got what? You got 3 moles of the glucose. The first bit is completed. Right now, and come to the second bit. Now see. So, calculate weight of 0.1 mole of the sodium carbonate. Yes, number of the moles of the sodium carbonate is equal. Calculate weight of the sodium carbonate by molecular weight of what? Molecular weight of the sodium carbonate. Yes. How you get gram molecular weight of the sodium carbonate? We get 23 into 2 plus 1 into 12 plus 3 into 16. That is equal to 106 grams. Right here 106 grams. So number of the moles of glucose is what? 0.1 mole. So from that, therefore, the weight of the soda ash. What is soda ash? Na2CO3 we write as 10.6 grams. That is right, Nana? So therefore, the weight of Na2CO3 is what you get? 10.6 grams. Simple explanation, no confusion of the explanation. And see the next question. Calculate number of the molecules present in 1.12 into 10 power minus 7 cc of gas at STP. Number of the molecules in 1.12 into 10 power minus 7 cc. Cc means what? ml of the gas at STP. 1 cubic centimeter is what? 1 cubic centimeter is equal to 1 ml. What I am saying? 1 cubic centimeter is equal to what? 1 ml. Therefore, STP is asking, you are very well. STP means what? 22,400 cc of the gas. 22,400 cc of the gas equal to Avogadro number of the molecules. No, because it's given in the cc. See the question carefully. Given in the cc. 22,400 cc of gas is equal to Avogadro number of the molecules. But in the question, how much is given? 1.12 into 10 power minus cc. That is equal to what you write? 112 into 10 power minus 9 cc of the gas. 112 into 10 power minus 9 cc of gas containing how many molecules? X molecules. And classification 22,400X is equal 6 into 10 power 23 into 112 into 10 power minus 9. So unsimplified, you got the answer. So how you get the simplification for that? So you write 112 into 6, that becomes 670 into, that is 1140 by 22,400. Now that becomes, you get divided by 22,400, you get 0.03 into 10 power 14, that is equal to 3 into 10 power 12 molecules are available. Understood, Nana? Simple logic, no confusion in this question. Very easy, Nana. 22,400 cc of the gas having Avogadro number of the molecules. Therefore, 1.1 to 10 power minus cc of gas having how many molecules? X molecules. Now, based on that, and simplified, the X value you get as what? The X value you get as 3 into 10 power 22 molecules you got. How many molecules you got? 3 into 10 power 22 molecules you got. And the next question, Nana. So what is redox concept? Give an example. A simple question. Redox concept means what? One species is oxidized, other species is reduced. Zinc solid added to aqueous copper sulfate solution. Now the zinc solid is added to aqueous copper sulfate solution. You get zinc sulfate aqueous solution. Zn plus 2, S4 minus 2, and the copper is precipitated. That is called the redox type. See, simple. Here zinc in what state? Zinc in the 0 state. The 0 state of zinc changes to plus 2. 0 becomes plus 2 is called what? Oxidation. Now the plus 2 of the copper reduced to what? The plus 2 of the copper reduced to copper of the 0. Plus 2 becomes 0 means what? Is called reduction. That is the example of what? Example of the redox reaction. Simple logic. Right, Nana? And what is meant by significant figures? Yes. Actually, the significant figures are defined as what? The significant figures are defined as these are the meaningful digits. What I am saying, Nana? These are the meaningful digits which are taken into account of the experiment. Which are taken into what? Into the meaning of. So repeat once again. Significant figures are defined as these are the meaningful digits which are taken into the experiment, okay, that is the meaning of what? Significant digits. And this significance disease explains the accuracy and precision of the experiment. The significant figures explains what? Explains accuracy. What is the accuracy? Perfection of the experiment. Accuracy of the given experiment. What I am saying, explains the accuracy of the given experiment. Simple logic, no confusion of the logic. Right, Nana? Repeat once again. So what are significant figures? So these are the meaningful digits which are taken into the experiment. These significant figures explains what? Accuracy of the given experiment. What is accuracy? Perfection of the given experiment. Right now. And see next one. So the empirical formula of the compound is given. Its molecular weight is 90. What is the molecular formula? Now see. The empirical formula compound is CH2O. Its molecular weight is 90. What is the molecular formula? Simple logic, Nana. Empirical formula weight into N is equal to molecular formula weight. Here empirical formula is given. What is the empirical formula is given, Nana? 90. Nana, given. Aspiring gamer, you asked about second phase counseling, but I am saying IPE questions. I don't know, brother. You check the on the internet, it is visible, Nana, where the second phase start. Because we have no time to teach the classes. What is the use of the second phase for me? You check out on that net, Nana, Bangaram. You check out on net, Bangaram. So this is what? CH2O. First you write what? Empirical formula weight. How you get, brother? 12 plus 2 plus 16. That is equal to 30. Understood, Nana? 30. Yes. From that, empirical formula weight is 30 into N. N means what? Whole number. And you get molecular formula weight. So what is the molecular formula weight is? That is 90. So on simplified, N is equal to 3. N equal to what, Nana? So N is equal to 3. Therefore, molecular formula of compound. Therefore, what you write, Nana? Molecular formula of the compound is equal to empirical formula whole N. So from that, so this is what? CH2O whole N. N value is what, Nana? 3. We write what? C3H6O3. What is the answer you got? So, tell me.
Empirical formula into N.
Yes, Nana. That is relation between the empirical formula weight and molecular formula weight. Relation between what, brother? Empirical formula weight and molecular formula weight. Therefore, the molecular formula of the compound is what? The molecular formula of the compound is C3H6O. Right. And see, what is disproportion reaction? Give examples. Simple logic. Disproportion reaction means what? In the given redox reaction, see the statement, Nana? In the given redox reaction, same species self-oxidized as well as self-reduced. Repeat once again. The same species is what? Self-oxidized as well as self-reduced. That is the meaning of what? Disproportion reaction. Give an example. Simple example. MnO4 minus 2. Manganese in the plus 6 state gives rise to what? MnO4 minus. So manganese in the plus 7 state Now the same MnO4 means becomes what? MnO2 and in the plus 4 state. Example of disproportional reaction. Now see, plus 6 changes to plus 7 is called what? Is called oxidation. And same plus 6 becomes what? No, no. Same plus 6 becomes what? Plus 4 is called reduction. Simple logic, no confusion. So plus 6 becomes plus 7 is called oxidation. Same plus 6 becomes what? Plus 4 is called reduction. Example of what? Disproportional reaction. That means what I am saying, same species is what? Self-oxidized, self-reduced in the given reaction. That is the meaning of what? Disproportional reaction. Therefore, disproportional reaction is also called what? Auto-redox reaction. Okay, what I am saying? Auto-redox. What is the meaning of auto? Self-oxidation, self-reduction. Right, Nana? Yes. So what is comproportional reaction? Give examples. Next one, Nana. Comproportionation. How you define comproportionation? No regarding. See, comproportionation reaction means the oxidation state of the product. What I am saying, Nana? The oxidation state of the product in between the oxidation states of two reactants. What I am saying? The oxidation state of the product in between the oxidation states of what? Oxidation states of the two reactants. That is the meaning of comproportional reaction. Simply said that is the reverse of what? Is the reverse of disproportional reaction. Reverse of the auto-redox reaction is example of what? Is example of reverse. Reverse of the auto-redox reaction. Repeat once again, Anna. The oxidation state of the product in between the oxidation states of the two reactants. Therefore, it is the reverse of what? Reverse of the auto-redox reaction. Now, one example I said. Say for example, copper in the plus 2 state. Copper in the what, Nana? Plus 2 state becomes what? Copper in the plus 1 state. And copper in the, wait 1 second, the same reaction getting in reverse manner, Nana, understood easily. Copper in the plus 2 state and copper in the metallic state means what? 0. That gives rise to what? Copper in the plus 1 state. That means the oxidation state of the plus 1. The oxidation state of the plus 1 in between the 0 comma plus 2. The oxidation state of the plus 1 in between the what? 0 comma plus 2 like that. Say for example, Ag plus 2. Ag plus 2 and Ag0 becomes what, Nana? Ag plus. Understood what I am saying? That means what? The oxidation state of the product plus 1 in between the plus 2 comma 0. In between what, Nana? Plus 2 comma 0 like that. Is the example of what? So the plus 1 is there in between 0, in between plus 2, example of what? Disproportion.
Disproportional reaction.
That means reverse of disproportion. Reverse of disproportion is called what?
Comproportional reaction.
Like this. Honest students is clear? Honest students, please tell me, Nana. Simple logic. Repeat once again. The oxidation state of the product in between the what? Oxidation states of the two reactants. That means is reverse of what, Nana? Reverse of the auto-redox reaction. That means oxidation state of copper plus 1 in between the plus 2 comma 0. Oxidation state of silver plus 1 in between the 0 comma plus 2 is example of reverse of disproportion is called comproportional reaction.
Yes, sir.
Simple logic. See the last question. How much volume of CO2 obtained by STP heating 4 grams of limestone? So limestone is the solid. On heating, you get what? CaO solid plus CO2 gas. Simple logic. Here, according to equation, you take 100 grams. See, 100 grams of the limestone on heating, you get what? So, what is given? How much volume of CO2 liberated? So, you get 22.4 liters of the CO2 gas liberated at STP. Yes or no? According to the question, how many grams taken? 4 grams is taken. Therefore, 4 grams of the CaCO2 on heating, you get X liters of the CO2 gas. Therefore, so 100x is equal 4 into 22.4 liters. So exactly this is 25 times is cancelled. Now x is equal 22.4 by 25 5 liters, that equal you got like this. So how much you got, Nana? So 22.4 divided by 25, get 0.896 liters, that is equal to 896 ml. This is your base class. Understood, Nana? Simple. According to equation, for 100 grams of limestone, you get 22.4 liters of CO2 gas STP. For 4 grams of the limestone, you get X liters of the CO2 gas, that is what? 0.896 liters, that is equal 896 ml of the CO2 gas is liberated. Right, Nana? Thank you very much.